Hi everyone. In this class, we learn how to find LCM and HCF in different methods. Already we learned in first class, class 1, we learned definitions and uses, applications. Also we learned that multiples and factors. Okay, about these things we learned in previous class. If anyone not listen or not watched the previous class 1, please watch the video which is in my channel, and also I given the link of the first class in the description. Please watch it, and then only we can understand this class too. Okay, now we learn how to find LCM in different methods. But here we have to know how many methods are there to find LCM. First we take LCM, and how many methods are there to find LCM. Actually here we have four methods. Four methods. Four methods are there to find LCM. The first one is listing multiples. This is the first method, and the second method is division method or short division method, and also called as synthetic division method. I will explain that after completing this. And the third method is factorization method, and the fourth method is powers of prime factorization method. And these four methods are very important, and the first method is listing multiples. And by taking one example, here one example, what is the LCM of 12 and 15? We should find by using first method first. Okay, here the given numbers are 12 and 15. To find LCM of 12 and 15 by using listing multiples, first we should write the multiples of 12, multiples of 12, and also multiples of 15. First we have to write multiples of the given numbers. Maybe they are two numbers or three numbers or more numbers. We have to list the multiples of the given numbers first. First we should write multiples of 12. Here 12 is a multiple. Already in the previous class we learned about multiples, how we can find the multiples of a number. We learned in a previous class, that is class 1. If anyone not listen, please watch the video which I given the link in the description. So 12 and 24, 36, 48, 60 and 72 dash dash etc. Next to multiples of 15, 15, 30, 45, 60, 75 and dash dash dash. These are the multiples of 12 and 15 written. And in the next step, a common, actually LCM means least common multiple, we know that. So first we should write common multiples. Common multiples. What are the common multiples here? 60 and 60 is common multiple. What is the next common multiple? We know 120 is the multiple of 12. 12 10 ja 120, and 120 is also multiple of 15. That is why next multiple is next common multiple is 120, and in the next common multiple will come as 180 and as etc. Here what I am explaining to see here, common multiples of any two numbers or more numbers are infinitively number of common multiples are there for any two numbers or more numbers. So 60, 120, 180 and dash etc. Next will come 240 will come. Like that there are infinitively common multiples are there. Among those we have to take least common multiple. So here least common multiple is equal to this is 60. This is the least common multiple. That is why therefore LCM of 12, 15 is equal to 60. The 60 is the LCM of 12 and 15. This is about this first method. And the second method. Second method is division method. In this division method, we take the given numbers. Two numbers are more numbers. We take 12 and 15, and we have to draw one vertical line like this. And this is a divisors place, and these are the dividends. 12 and 15 we should write as dividend, and here will come one divisor. We take any prime number only. Okay, in this place we should take, that means in divisors place we take only prime numbers. That also we take small to big we take. Okay, here 12 and 15. Here 12 and 15 are divisible by first prime number 2. So 12 and 15 are not divisible by 2. Next prime number is 3. 12 and 15 are divisible by 3. So we take 3. So 3 4 are 12 and 3 5 are 15. And here 4 and 5. 4 and 5 are not divisible by any one prime number. That is why we stop the numbers. That means we stop the division here. Here you see here 3 4 are 12. That means here quotient we should write. In this place quotient, that means 12 divided by 3, then we can get 3 4 are 12. That is why this quotient we should write here. As with 15 also divided by 3, 3 5 are 15, and this quotient is 5, we should write here. And then 4 comma 5 are not divisible by any prime numbers. 2 3 4 2 3 5 7 like that. Here any one only divisible, but two numbers are not divisible by at least one prime number. That is why we stop this process, and then we write LCM of 12 comma 15 is equal to this 3 into 4 into 5. How we can take this? These numbers we take 3 into 5, 3 into 4 into 5. So 3 4s are 12, 12 5s are 60. So 60 is the LCM of 12 and 15. This is the division method. Okay, if in any example 3 numbers or more numbers given, we should write here only, and then we divide. But I will explain in the next example. 3 numbers or more numbers I will take, and then I will explain that. Okay. Next the third method. Next third method is prime factorization method. Third method, prime factorization method. In this prime factorization method, we take 12 and prime factorize it first. How we can only one number we take 12, This 12 is divisible by first prime number 2, take 2 and divide 12, and then we can get 6 is the quotient. So you write here 6, and then the 6 divisible by 2, again 2 3 is 6. This is completed. Because of 3 is a prime number only, therefore the prime factorization of 12 is prime factorization of 12 is equal to 2 into 2 into 3. 2 into 2 into 3. 2 2 is 4, 4 3 is 12. Again we can get 4, 12 only after multiplying this. Also we take 15 and factorize it. This 15 is divisible by prime number 3. It is not divisible by 2. Then we take next prime number, that is 3. 3 5 is 15. 5 is prime number only. Then we stop the process, and then prime factorization of 15 is equal to 3 into 5. Okay, this is prime factorization completed. And now we take here any common factors are there. First we have to find these common prime numbers. So we should write here common factors or prime factors. Common prime factors. Common prime factor is only one, that is 3. And now we should write other prime factors. What are the other prime factors? 2 into 2 and here into 5. 2, 2, 5 are other factors. This 3 and this 3 are common. That is why we can we have to take here common factors. Okay, therefore LCM of 12, 15 is equal to common prime factors into other prime factors. This is the formula. Okay, common prime factors 3 into other prime factors 2 into 2 into 5. 2 into 2 into 5. And then 3 2 is 6, 6 2 is 12, 12 5 is 60. So 60 is the LCM. This is the way of finding LCM by using prime factorization method. And the next method is the powers of prime factorization. Powers of prime factorization. Here I am writing. Fourth method is powers of prime factorization method. In this powers of prime factorization, first we find the prime factorization of these two numbers we should find, and then first in this method also we have to find this one total. Powers of prime factorization only up to here we should find, and then here this 12, that means prime factorization of 12 is 2 into 2 into 3. And now here is very important. We have to change this prime factorization into powers of prime factorization. Here 2 into 2 are both the same factors. That is why we can write as 2 to the power of 2 into this one 3 to the power of 1. Okay, next to 15. This 15 3 into 5. 3 into 5. This one we can write as only 3 to the power of 1, 5 to the power of 1. And then we should write LCM. LCM of 12, 15 is equal to. Here is very important in both powers of prime factorization, this one and this one. This is common. 3 is a common. First we take a common factor. First we take a common factor, and here power is 1, here power is 1. Both are same. There is no problem. But if they are different, powers are different, we should take the big power. Big power. It is very very important. So here 1 and here 1. So we need not to we have no problem here because of powers are equal. If powers are different, we take the big power. Okay, but here 1 only, it is power of 1, and into there is no common factors here 2, here 5 only here. There is no common. That is why we write as it is the other factors 2 to the power of 2 into 5 to the power of 1. Okay, 3 to the power of 1, 3, 2 to the power of 2, 4, 5 to the power of 1, 5 only. So 3 into 4 into 5, 60. Okay, this is 60 is the LCM of 12 and 15. Okay, still now we learnt how to find LCM of 12 and 15 by using 4 methods. First method is listing multiples, second method division method, third method prime factorization, and fourth method powers of prime factorization method. But here which method is which method is useful to us? Which method is easy? This is important here. Here every method is important only, but this division method is easy to find big numbers. If the given numbers are very big numbers, 3 digits or 4 digit numbers, we can't find listing multiples. It is very difficult to find multiples of big numbers. But we can find easily LCM of big numbers division method. Of course, also for the big numbers, also we can find LCM by using prime factorization and powers of prime factorization. Here, the useful of third and fourth method are very very important. Especially this fourth method, powers of prime factorization is very very useful in the competitive examinations. How we can use that in the competition examinations? We can I will explain in the next class. In the class 3 I will explain. Okay, if you like this video, if you satisfied with this class, please like the video and also subscribe our channel, and also share to your friends and relatives. Thank you very much.